Good morning to one and all. My name is Dr. D. Sudhakar. Today we are going to discuss about the water jet machining process. The water jet machining is also known as water jet cutting. Is a non-traditional machining process that uses a high velocity jet of water to remove materials from the workpiece surface. It means that the water jet machining is one of the non-traditional machining process, uses the mechanical energy in the form of water jet, and this water jet is used with high velocity to remove the material from the workpiece. This is the schematic diagram of the water jet machining. In this one, the main components are like this is the fluid supply box, then this is the intensifier, and then it will go to the accumulator and it will controls the flow. It is a controller, and then it will separate the valve. From there it will be transferred to the nozzle. From this nozzle it converts the high pressure energy into high velocity of water jet, and this water jet impinges over the surface of the workpiece, and because of this high kinetic energy of jet, some very less amount of material is removed from the workpiece, but we are going to get very good surface finish. And the distance between this workpiece surface and this nozzle tip distance is known as a standoff distance. Now coming to the elaborate explanation of this water jet machining. The water jets are used in this process, which acts as a device in the form of a water saw. Actually, in conventional machining process, in order to remove the metal from the workpiece, generally we use the cutting tools. It may be single point cutting tools or multi-point cutting tools, like a drilling machine, boring cutting tool, single point cutting tools, or drill bits like that. But here, physically, we are not going to use any cutting tools. Instead of these physical cutting tools, we are using water jet as a cutting tool. So the water is rapidly raised and focused on the target workpiece in this process. This is the process what we are going to use in this water jet machining process. And this water jet machining is capable of using abrasive particles mixed in water jet materials and some metals, high velocity and abrasive particles. Some processes use no abrasives at all. So in some places we can mix along with the water, we can mix abrasive particles, and without abrasive particles also we can impinge this water jet as a cutting tool, and we can remove the metal from the workpiece. And these are known as pure water jet machining process. It means that if you use the abrasive particles with water, then it is called as abrasive water jet machining. But if you use pure water jet as a cutting tool, then it is known as water jet machining process only. And this machining process uses means the water jet machining process uses the water pressure ranging from 200 megapascal to the 400 megapascal, and this pressure varies depending upon the workpiece from which the material to be extracted. Means depending upon the material to be extracted from the workpiece, based on that we are going to decide the how much quantity of pressure with which we have to supply this water jet. And this process is similar to the natural phenomenon of water erosion. Just why we are going to use the water erosion? Generally, if you pour water on any surface or on earth, then automatically it will remove the mud or the material on the any workpiece, whatever it is there, and that is due to the erosion process. The same process what we are going to using in this water jet machining process. It is primarily used to remove the material from the non-metallic and soft materials such as plastics, rubber, and glass. So in this process, high velocity of water jet is used to remove the metal from the workpiece. The basic principle of this process are that the water jet's kinetic energy must be converted into a pressure energy. In order for it, it removes the metal from the workpiece. When water jet collides with the workpiece, means it impinges over the workpiece with kinetic energy. The kinetic energy is converted into the pressure energy. Because of this pressure energy, a large amount of stress will created on the workpiece, and because of this one, a tension material will be begin and it move away from the workpiece. So because whenever we supply very high velocity of abrasive particles on the surface of the workpiece as a stream, it converts the kinetic energy into pressure energy. Because of that one, this some amount of material is removed from the workpiece and it is flow away from the workpiece through this water jet. Sorry. Coming to this working principle of water jet machining, the working principle of water jet machining is based on the water erosion. Means water is used to erode the material from the workpiece. The material is expelled, means whatever the material we are removing from the workpiece, that is known as expelled. This material is expelled when high velocity jet of water strikes the surface. The soft materials are machined using pure water jets. So if you want to remove the material from the soft materials, then we can use pure water jet instead of mixing the water and abrasives. To cut hard materials, however, some abrasive particles are mixed with the water, and that machining process is known as abrasive water jet machining. So these are the parts of the water jet machining. This is the water tank in order to store the water, and then from here we are going to supply it, pass through the valve. We can close or we can stop or start the flowing of water, and then it is supplied to the pump by means of the main intensity of pump is to collect the water, and it will be supplied to the intensifier. The main purpose of this intensifier is to increase the pressure of the water, and after that we are going to store in the accumulator. From there it will be supplied into the nozzle. In between this accumulator and nozzle, these hydraulic controls and pressure gauges will be there. By means of that one, we can measure with how much quantity of pressure we are going to supplying the water into the nozzle. And these nozzles are made of like a sapphire or hard materials, which is having high wear resistance. And if you want to mix any abrasive particles, then this is the abrasive feeder from which we can supply the abrasive particles into a nozzle, and here the water and abrasive particles will be mixed, and this pressure energy the high pressure water and abrasive particles are mixed together, and it will be coming out from the nozzle and enter on the and strikes or impinges over the surface of the workpiece. And the distance between this nozzle tip and the work surface is known as standoff distance. And this is the fixer, and this fixer is used to hold the workpiece. Now coming to the parts used in, we are going to discuss about the parts which are using in the water jet machining process. The first one is the reservoir. A water reservoir is used for storing the water, and that will be used during the machining process. So the main purpose of the reservoir is to store the water, and which is using in the during the machining process. Sorry. The reservoir is generally located somewhat above the entire setup. So this is done to ensure a continuous and uninterrupted flow of water. Now coming to the hydraulic pump. The hydraulic pump is powered from 30 kilowatts electric motor and supplies oil at a pressure as high as 117 bars in order to drive a reciprocating plunger pump termed in this intensifier. So in this intensifier, we are going to using one reciprocating plunger. So with that one, we are going to increasing the pressure of the water up to 117 bar. The hydraulic pump offers complete flexibility for water jet cutting and cleaning applications. It also supports the single or multiple cutting stations for increased machining productivity. So if you want to cut one material at a time, it is possible. If you want to cut on different materials, means multi stations are there. Suppose multi cutting stations are there. For all those stations, we can supply the water pressure with required quantity and required pressure also. Now coming to the hydraulic intensifier. The intensifier accepts the water at low pressure, means typical at 4 bar, and expels it. Though an accumulator at high pressure up to 3000 to 4000 bar. The intensifier converts the energy from the low pressure hydraulic fluid into ultra high pressure water. That is the purpose of this hydraulic intensifier. The hydraulic system provides a fluid power to a reciprocating piston in the intensifier center section. Now coming to the accumulator maintains the continuous flow of high pressure water and eliminates the pressure fluctuations. So in order to overcome the problem of pressure fluctuations, we are going to use the accumulator, and the main purpose of this accumulator is to control the flow or to maintain the continuous flow of high pressure water without any obstructions like a high pressure, low pressure, medium pressure, like that. Instead of that fluctuations, the continuously, constantly, whatever the pressure of water we require, and that much amount of pressure, it can be supplied with the help of this accumulator. And it relies on the compressibility of water 12% at 3800 bar. So in order to maintain the uniform discharge pressure and water jet velocity when the intensify changes its direction. Now the next part is high pressure tubing. The high pressure tubing transports the pressurized water to a cutting head. Typically, tube diameters are 6 to 14 mm. The equipment allows the flexible movement of the cutting head. The cutting action is controlled either by manual or through a remote control valve specially designed for this purpose. Next, coming to the nozzle. In water jet machining, it is a device that converts the pressure energy of water into kinetic energy. Means the main purpose of this nozzle is to convert the pressure energy of water into the kinetic energy. The nozzle in this case converts the pressure of the water jet into a high velocity beam of water jet. To prevent erosion, the nozzle tip made of ruby or diamond. So when it is coming out, when the water is coming out from the nozzle, it will be it is having very high velocity, high kinetic energy. Because of that one, some the diameter or the internal diameter of the nozzle may erode or change. So in order to overcome that problem, the nozzles are made of the hard materials like ruby or diamond. Now coming to the control valve regulates the pressure, both the pressure and the flow of water, and direct it to the flow regulator. So its main purpose of this control valve is to regulate the both pressure and flow of water. The pressure energy will be converted into kinetic energy at this point. So if you close the valve, then automatically the pressure energy will be converted into the kinetic energy. Next, flow regulator. Flow regulator regulates the flow of water coming out from the control valve. This flow regulator will be located after this control valve so that it controls or it regulates the flow of water coming out from the control valve. After adjusting the flow regulator, the water will pass through the nozzle and converting the high pressure of water into a high velocity of water. Next, catcher. The catcher acts as a reservoir for collecting the machining debris entrained in the water jet. So after, when this high velocity water jet impinges over the surface of the workpiece, automatically because of this erosion process, some amount of material will be removed from the workpiece. So whatever the material is removed and whatever the water is coming out, those things, but both water and debris is collected. Moreover, it reduces the noise levels associated with the reduction in the velocity of water jet from Mach 3 to subsonic level. So during this machining process, very huge amount of noise is also developed. So in order to reduce that noise, we are going to use this catcher for the collecting purpose, and at the same time to reduce the noise of the operation, and it will help to operator who are working over there. And coming to this, now coming to the working of water jet machining. First, a pump is used to transfer the water at high rate.